at some Module 5 examples. So looking at the algebra of functions here at the beginning. With the algebra of functions, we're going to look at creating sum, difference, product, quotient functions and analyze them, talk about their domain, their characteristics. Now, this first example, it wants to find a new function of x by finding the difference with w and f. Find w minus f of x. So let's go ahead and begin. Now, w minus f of x is equal to w of x minus f of x. So let's go ahead and begin substituting. What is w of x? W of x up there is given to be the function 4x plus 3, a linear function, minus f of x, which is given to be a quadratic function, x squared plus 1. Well, what we need to do now is simplify. So we'll go ahead and distribute. So that gives me 4x plus 3. Let's go ahead and clear the parentheses. Minus x squared minus 1. And then if we can simplify, which we can, a couple of like terms, right? We can go ahead and combine those two constants. They combine to 2. So let's go ahead and write it like in standard form. We'll put our degree 2 term up front, leading to polynomial, plus 4x, and then a plus 2. So negative x squared plus 4x plus 2. So what do we come up with? Here's our difference function, right? Here's w minus f of x. So it also asks for domain. Now, domain is always created by looking at any domain restrictions on the original functions. So with wx and f of x, they had a domain of all real numbers. There are no undefined values in a linear and a quadratic. They're polynomials. And same thing happened with our result. We get a quadratic. So no undefined values are in play here. So our domain is all real numbers, x. So as we write out our domain, let's go ahead and put it in interval notation. So negative infinity to infinity. Now, all real numbers, x. Okay. Moving on, let's go to example B. Let's look at h plus r of x. So I want to take a quick note here on this one. All right, h of x in this example, h of x is a rational function, 5 over x. All right, and r of x, write it down, is also what we call a rational function. We've got our domain variable x in the denominator. Well, that's important. I want you to make note of that. So as we talk about creating this function, we do have a couple of restrictions on the domain already. So what I want to do is talk about what we cannot have. We cannot have a denominator of 0. So x cannot equal 0. So that gives us one domain restriction. And here we got x plus 7. Well, again, it cannot equal 0. So as we solve that for x, we get x not equal to negative 7. So we talk about domain, we know x cannot equal 0 or negative 7. So we need to make that note before we begin. All right. Now we could come up with something new in the end. Let's go ahead and begin working this sum function. So finding h plus r of x, again, is equal to h of x plus r of x. So we'll be adding two rationals. I got 5 over x plus x minus 3 over x plus 7. Now, you need to simplify that. So we're adding these, right? We can't add unless we have a common denominator. So let's go ahead and rewrite it with a common denominator. Let's get a LCD, which would be x times x plus 7. So I'm going to go ahead and rewrite these. So if we rewrite, we're missing the x plus 7 factor. So we can multiply the numerator and the denominator, x plus 7, to make that LCD happen. And over here with this fraction, we're missing the x, so we can go ahead and multiply by x. So now I can add them together. So as I'm looking at the sum, all right, of these two functions, we can begin to write that out. So we're going to have 5, all right, times x plus 7, the missing factor in that first term, plus and the numerator from the second fraction. Again, now we can combine them. Since we're dealing with an LCD, we got a common denominator. We can add or subtract fractions at that point. And here we got x minus 3 times x. And all of that is being divided by our LCD, our common denominator, which is x times x plus 7. All right? So again, writing it in that denominator. Now let's simplify things. So the numerator we can work on. So we should distribute next. Let's go ahead and multiply that 5 through. Clear the parentheses. 5 times x is 5x, right? And then 5 times 7 is 35. And then as we go through the second, we got x times x minus 3. X times x is x squared. X times negative 3 is negative 3x. All divided by x times x plus 7. And in the numerator, now we got some like terms. So I've got a x squared, got a 2x, and I've got a plus 35 in the numerator, times x over. And you'll notice in the denominator, I'm leaving it in factored form. So I'm not distributing, I'm not writing x times x plus 7. I'm not writing x squared plus 7x. I'm going to leave it in factored form because I do like to see if I can factor the numerator. Well, the numerator in this problem is not something we can factor with integers. So we're not going to be able to take the numerator any further. There's no common factor in play on this one. So with that said, we found our new function. So there's our sum function. So there's h, right, plus r of x. Now from that, we have these, right, denominator factors of x and x plus 7, which produce nothing new as far as restrictions. We've already stated x can't be 0, and with x plus 7, we can't have negative 7. So we're ready to write our domain out. So as you're looking at your domain, it might help you. I always like to see it. We talked about in class, visualizing our domain. Let's place negative 7 and 0 on the x line. So here's all real numbers x, our domain values. So with negative 7 and 0 being undefined values, our domain are all the other real numbers. So you can see there's 3 intervals we're going to write in here. So all x values less than negative 7. Need a parentheses on negative 7. We don't want to include it, not a bracket. We got all the values greater than negative 7 and less than 0. And then we have 0 to infinity. So there's our domain, right, of this function. So again, domain, there it is in interval notation. All right, so that's a good example. Looking at a rational function, you do have to be careful with domain restrictions. Let's do the same thing, example C. We got h over r of x. All right, well, let's go ahead and talk about h and r again. We already know from h and r we have domain restrictions. X cannot equal 0 and x cannot equal negative 7, right? H of x has that denominator of x. R of x has that denominator of x plus 7. Now this time as we work the algebra, right, what is h over r? That's h of x divided by r of x. So we're going to divide these functions. So we're going to take h, which is 5 over x, and we're going to divide it, right, by x minus 3, right, over x plus 7. Now we got to simplify that. So we're looking at what we have in front of us. Right? We have a fraction sitting inside of another fraction. We don't want to leave that. So we need to clear out this fraction denominator. So we can do that easily. There's only one term down there. So we just multiply by the reciprocal, right? If we're dividing by a fraction, same thing as multiplying by the reciprocal of that fraction. So as we do that, now we got a product of two fractions. There's no common factors in the numerators or denominators. So again, we can go ahead and combine these and multiply the numerators and denominators together, and we can leave it in factored form. You don't have to distribute. I always like to leave it in factored form anyways, so I can look for common factors to divide out. But again, here's our new function. Here's h over r, right, of x. Now, with that said, I want you to look now at our denominator. we've got a denominator of x, and now we have a denominator of x minus 3. Well, x minus 3 cannot equal 0. So we get a new domain restriction, right? We got x equal to 3. X equal 3 is a problem. So x cannot equal 3. So we got 0, -7, and now we got a positive 3 coming into play, right? We got to include that one. So be careful, another domain restriction. So let's go ahead and look at our domain. So if you want, we can build our x line. Now we've got 3 undefined values in this example, -7 being the smallest. And we got a 0, and we got a 3. So looking at all real numbers, -infinity to infinity, where are our x values for this function? If we were to graph it, where would our graph take place along the x-axis? Remember, that's what you're finding with domain. Well, we got -infinity to -7, right? All x values less than -7 will be on our graph. We got those values greater than -7, less than 0. So between -7 and 0, there's our second interval. And then we got the values between 0 and 3. And then from 3 to infinity. There's our domain. We got actually 4 intervals, right, that we had to write in here based off these 3 undefined values. So be careful with your restrictions as you're looking at those. Let's move on to part D. Let's find another one. F divided by g of x. Now working with f and working with g. So let's keep in mind what these two functions are. X squared plus 1, which has no domain restrictions. And g of x. Now this is one we have to be careful with. A square root function. Well, square root functions is an even root. We cannot have a negative number in an even root. So remember, when you find a domain, you need to make note of that. So find out when your radicand is greater than or equal to 0, because we got to restrict it to those x values, because it cannot be negative. So less than 0, we'd have a problem. Negative number, we cannot take the even root of negative, not with real numbers. Domain, we're talking about real numbers. So let's go ahead and solve this one. So as we solve for x, right, we go ahead and get negative x greater than or equal to -1. Now be careful when you're dividing or multiplying by a negative in an inequality, you got to flip or reverse the inequality symbol. So that means x can be less than or equal to +1, right? -1 divided by -1. So those are domain restrictions. So let's write that down over here. X is going to have to be less than or equal to 1 right now, just based off the g function. Now back to our problem, we're going to find the quotient function, f divided by g. So x squared plus 1 divided by square root of 1 minus x. Now, that's it. We can't simplify, no common factors, but I want you to look at this denominator, right? We have our function. We found the new function of x, f over g. But it does have a new restriction, right? We know this cannot equal 0, right? This square root right here. Square root of 1 minus x, right? Cannot equal 0. So again, if you were solving that, what do we get? We get 1 minus x cannot equal 0. As we subtract 1 on both sides, we get what? Negative x equal or not equal -1, and we'll divide out our negative on both sides. So here's another restriction. So if we look at this as we're solving for x, we got x cannot equal 1. So back over here, as we look at writing out domain, well, that implies x must be less than 1. We got to exclude 1. X cannot equal 1. So again, make sure you make note of that. So there's our domain. So as we write out our domain, and we can put it in an interval notation, all x values less than 1 are in the domain for this function. -infinity to 1, a domain. So that's a good one. Even roots. We haven't talked about that one yet. Even root functions. Let's look at part E. Got f times w. Got a product function in this one. F and w. Now f and w are two functions, are quadratic linear. They don't have any undefined values. I'm just going to go ahead and begin writing out the work. We got f of x to multiply with wx. So x squared plus 1 multiply with 4x plus 3. Now our work will be distributing. Let's go ahead and multiply together. So we got to take the x squared, multiply it through. Let's go ahead and multiply together. X squared times 4x. Well, that gives us a 4x cubed. We got x squared times 3, which gives us a 3x squared. And then we got to take the plus 1. Let's go ahead and distribute it. Multiply all the terms together. 1 times 4x is 4x. 1 times 3 is 3. And then if you have any like terms, combine them, which we don't. So as you look, here's our new function. It's already in simplest form after we multiplied. So here's our product function. Here's f times w of x. Now, we don't have any rational terms. We don't have any even roots. No undefined values, right, with this one. There's no real number that would cause a problem. So that implies, right, our domain, all real numbers, neg infinity to infinity. We got a domain on this one. Okay. And moving on, let's go to our last example here. All right, got v dot g. All right, so v dot g. Now v, again, let's go back. Let's write down what v and g are. So v, this is a new function. We haven't worked with v yet. So with v of x, all right, what does it equal? 4 divided by x squared minus 9. And then, of course, g is our square root function. G of x equal to square root of 1 minus x. All right, so again, as we're looking at this problem, all right, we do have to talk about some restrictions. All right, we cannot have a denominator to be 0, so let's go ahead and take this v function. Before we even begin, we need to go ahead and talk about domain restrictions. We know that x squared minus 9 cannot equal 0, which implies what? So we solve for x, move that over, and then we take the square root of both sides. Well, even roots be positive or minus. We end up with two values. X cannot equal negative what? 3 or 3. So 3 or negative 3. Square root of 9 is 3, and then we got the negative square root of 9. So those are domain restrictions before we even begin. X cannot equal negative 3 or 3. All right, so let's keep that in mind. Now, g of x, we also remember from it, we know right here that 1 minus x, right, we've already talked about g, right, 1 minus x must be greater than or equal to 0, which implied x must be greater than or equal to 1, or less than or equal to 1, I think we found. So again, that's another restriction. So x cannot equal negative 3 or 3, and x must be what, less than or equal to 1. So we've got to add that to it. So our square root function has that restriction. So again, we worked that out in part D. You're going to look at details behind solving. I went ahead and skipped to the outcome. But let's do the product function. So v times g. So this is equal to v of x, right, times g of x. Well, v of x is equal to, again, 4 divided by x squared minus 9. Multiply with g of x, which is our square root function, square root of 1 minus x. And as we multiply those, we get 4 times the square root of 1 minus x over x squared minus 9. Well, no common factors. We can stop there. There's our function. There's our function v times g of x. Now, as we look at it, there's no new restrictions. We know the denominator can't be 0. We've already mentioned 3 or negative 3 was the only ones that cause that. So we're ready to write in our domain. So as our domain goes, this is definitely another one might be helpful, right, to draw in the x line. So we've got negative 3 as a undefined value. So let's make a little open circle. All right, we've got, what else? We got 1. So again, got to be less than or equal 1. I'll put 1 on here. And then we got 3 over here, can't equal. But with our domain, x must be less than or equal to 1. Well, that means 1 is in domain. That means everything to the right of it is not. So that means we got to exclude, right, these values. So again, it got to be less than or equal to. With that said, now usually we go all the way to negative infinity, right? But we have a undefined value, right? As we look at that graph, right, we have a break at negative 3 because it's got to be excluded because it makes our denominator 0 if we plug in negative 3. So as our domain goes, all right, we got actually 2 intervals. Negative infinity to negative 3 with a parentheses, right? Or all values greater than negative 3 and less than or equal 1. Now you need a bracket on 1. We've got to include that. But there's our domain, right, in interval notation. There are those 2 intervals for that. So that's a good one too. Again, reviewing domain, that topic we've been talking about since the beginning of the unit. We defined a function. We talked about a relationship with domain and the range. So I hope that helps you with those type of problems. We'll take a break and continue with some more.